webinar on how to produce more product at a lower cost and operate safely while protecting the environment. As a reminder, you will receive the recording of today's presentation once it is finished. If you have questions during the presentation, please ask them at any time using the Q&A function at the bottom of your screen. I encourage you to use your name and not ask the question anonymously, because if we do happen to run out of time to address all the questions, our presenters will be able to reach out and address your questions after the webinar. I'll now turn it over to our presenter today, John Bledsoe, Energy Practice Lead at Confluent, who is also joined by Dave Klein.
Thank you, Jessica. And thank you, everybody, for joining us today. We hope that all of you that were impacted by the winter weather in Texas a couple of weeks ago are doing well along with your families. We were originally going to have the webinar during that period of time, and we pushed it out to March so that way everyone would have time to take care of their families. So thanks again for joining us today. So today we're going to chat about industry trends, use cases, and we will also have a question and answer session. I'm John Bledsoe. I lead the energy practice here at Confluent along with Dave Klein. Dave and I joined Confluent due to the increased demand from the energy industry for real-time data, as more companies have publicly stated that they are seeking Silicon Valley partnerships to leverage emerging technologies and innovate to produce more product at lower costs, operate safely, and be good stewards of the environment. We're seeing such a strong focus that more and more energy companies are putting members of their board that have Silicon Valley technology experience as they look to innovate and really leverage emerging technologies. So US production peaked at 13 million barrels per day in 2019, early 2020, and it quickly fell as the impacts from COVID and the Saudi-Russian price war rocked the market. During the shale boom from 2010 to 2014, when oil prices stayed in the range of over $100 a barrel, oil companies increased their production at staggering rates, and many went deep into debt in order to fund those operations. We have seen discipline increase from 2016 when oil bottomed out at $26.05 per barrel through 2020 and into 2021. Companies were focused on free cash flow, reducing debt, keeping production flat or minimally increasing production to more than 5% over 2020 levels. Companies like Devon Energy and Pioneer Natural Resources have instituted a fixed plus variable dividend program. Each quarter, shareholders receive a fixed dividend along with a variable dividend that's determined by the previous quarter's cash flow. Many companies are also buying back shares. CEOs from ConocoPhillips, Oxy, Pioneer, and others have stated that they will not grow production over 2020 levels. So companies must become more efficient in order to increase their profitability, insulate themselves from downturns, and increase shareholder value. The need for data science programs is increasing as squeezing every bit of value from data to improve drilling, completions, operations, and resource planning grows. Traditional or old data won't support the modern oil and gas enterprise. This is an interesting survey from E&Y. They surveyed oil and gas company executives who expressed that there is substantial room for improvement with data analytics, digital engineering, data science, and artificial intelligence. As a follow-up, they also had a survey of those executives, and you can see here how they're focusing on big data analytics as being a big part of their growth and positive impact to their organizations. So as you can see, analytics and technology are going to be key drivers going forward. Most companies are dedicated to supporting a sustainable ESG program as they look to reduce incidents, keep their employees, contractors, and the public safe, while also being a good steward of the environment. These are just a few examples of the loss of life and costs from previous incidents that we all want to avoid in the future. Another complication is that insurance costs are increasing. Lloyd's of London will no longer serve oil and gas industry after 2030, and many companies self-insure, which underscores the need for increased ESG and safety programs. So as we go forward, the need to minimize any incidents to minimize windshield time that employees and contractors use going from site to site increases. And that means more and more companies have to leverage digital technologies and leverage real-time technology. So what does it mean to be event-driven? Gartner highlights the needs for organizations to leverage event-driven architecture for real-time decision-making, IoT initiatives, and agile microservices. Many oil and gas companies have legacy architectures, and they look to Confluent to help them modernize so that way they can better support today's business needs. Companies like Netflix and others get a lot of buzz in the marketplace, but they all started off being purely cloud-driven companies, whereas oil and gas companies are looking to traditional companies like the Walmarts of the world that have adopted and been able to modernize their architectures and also modernize their businesses to better compete in the marketplace. So what is an event? It can be just about anything. Compressor readings, vendor information, an invoice, monitoring all the meters, outage detections, asset tracking, and certainly safety metrics. So anything that you can think of can be leveraged to run your business in real time. So event streaming is making new outcomes for our clients. And in the world that we live in, if you don't innovate and if you're not a disruptor, you will be disrupted. Think about what Uber and Lyft have done for ride sharing. You no longer call a cab and book an appointment and hope that they show up at the time that you've agreed to. Now you pull out your phone, you enter where you want to go. It quickly tells you what your options and your prices are. You select that option, and then you're updated in real time as to where that driver is. That's leveraging Confluent technology. That's all messaging. That's all event streaming. In the world of banking, we have a client that was leveraging batch updates as part of their fraud detection. And so they were doing batch updates every 10 minutes, and they became a Confluent customer and started doing their fraud detection in real time. We're saving them over $2 million a day. So when you get a text or an email or a phone call from your bank or your credit card provider asking if a transaction is legitimate, think of Confluent, because we're doing a lot of work in the financial services industry around that. And in the world of energy, companies have traditionally done batch analytics, and it's taken them days to get data in from the field, and then load it in a data warehouse, and then allow their data scientists and their analysts to analyze that data and make performance recommendations. Now we're in the world of leveraging real-time analytics as that data comes in, streams in from the field in real time, where companies can take a look and analyze that data in real time with historical context, so that way they can do predictive maintenance, predictive alarming, keep their employees and contractors safe, and better run their businesses in real time. So we'll talk about some use cases now. So this is a use case from the manufacturing world, but it translates very well into oil and gas, because the oil and gas industry has been adopting repeatable manufacturing-based processes for several years now, because they don't want to keep reinventing the wheel every time they have to do a process. They want to standardize those processes, refine them, and always make them better. But this is an example of one of our clients who is a global vehicle manufacturer, and they are leveraging Confluent to pull temperature, pressure, vibration, and other sensor data off of those sensors, like we would do in oil and gas, as part of their program to reduce the number of vehicles they produce with defects. This allows them to analyze in real time, stop the assembly lines, address the issue, and then go back into production. The business impact is that they're saving money on warranty claim costs, and it also increases their customer satisfaction, retention, and their market share. The J.D. Power Quality Awards are taken very seriously by these manufacturers, especially this one. We're proud to have them as a client. So exception-based field maintenance is becoming a bigger and bigger trend in the industry. This client is extremely focused on cost reduction. When you go to one of the cafeterias on their campuses, they will have examples on their table about different areas and ways that they're saving the company money. In this example, with what they're leveraging Confluent for with the exception-based field maintenance, they've reduced their headcount in the field by 80%. Previously, their field operators would go out to sites on a regular schedule with pad and pencil, maybe a mobile device that they could add some notes into. But there was a lot of windshield time and a lot of time driven in some bad conditions for them to go out and manually check these sites. Now with Confluent, they're streaming that data in real time. They're able to take action on that data with the historical context. And what they do is they will then dispatch their field operators to those sites on an exception basis to take care of an issue or an issue that they predict will happen. Those operators also have mobile devices with applications on them, kind of like the Uber for the oil field, where they can take action and also report on any other updates from different sites. Another benefit that the client has gotten from partnering with us is that they've been able to discover which service providers and contractors are responsible for the majority of the incidents and downtime that they've experienced. And so that has led them to not renew those contracts when they come up for renewal and only partner up with providers and contractors that do quality work. It's all about reducing downtime, increasing uptime, and keeping production levels predictable. Speaking of predictability, so we're seeing more and more customers want to leverage equipment predictive analytics. And when you think about that, certainly downtime is a killer and everyone wants to reduce the downtime. But if you can extend maintenance intervals, that's also a cost savings. And also being able to monitor the health of your equipment can save costs as well. That also helps them from a standpoint of working better with their suppliers because they can be predictive. That allows them to go ahead and order parts and order equipment on a better schedule because they're not just stockpiling parts and equipment. But it's really all about having that better insight to the equipment and operations to increase the revenue. Now, you can think about something else too. We saw what happened in Texas recently, and production assurance is another key area. And for example, if you are operating in a cold environment and you're having an issue with product going through the pipelines, is it because the temperature has dropped or do you have equipment failure? So we're seeing more and more need for companies to better manage the transport of these products and manage all those devices and equipment in the field. Another piece that's interesting too is what John Carpenter says there at the bottom, how the average uptime in the North Sea is 73%, and it reinforces the need for predictive analytics and data process at the edge. Comparatively, the uptime in the airlines industry is 99.9%. Now, granted, not every environment in oil and gas is the North Sea, but there are plenty of environments out there where they consider uptime 75% or even 80% fantastic due to the conditions that they work in. If we can help our customers do a better job with predictive analytics on their equipment, we can increase that uptime, and certainly will help them from a profitability standpoint. Digital twin is another interesting area. And as I was thinking about this today, I thought about what if digital twin could have been leveraged successfully in Texas when we were having grid issues. And when you think about being able to leverage digital twin and the role that Confluent can play, we can provide that data to a digital twin model in real time. So companies can actually do what if analysis. If they make changes, what's going to happen upstream of that change, downstream of that change? How is that going to impact business opportunities, efficiencies, and certainly compliance? And you also think about being able to better handle your operations. Companies are now also finding that there are times when they can take advantage of the market. And it may be something as simple as a competitor in the refining business notifies you and says, we've got excess product that we need to move and we'll make you a great deal. Well, how quickly can you determine what trucks you have available and where they are to get that product, or what pipelines are available, or what storage is available? So being able to manage your business from a real-time event-driven perspective can help you better make those decisions in a quickly and timely manner. Well construction is certainly a key piece. We have seen more and more clients impact how their providers are drilling wells. And it started off in the world of pad drilling, where clients discovered, hey, if we drill every stage for a 6-well pad, do all of stage 1 for all 6, then all of stage 2, all of stage 3, all of stage 4, not only can we drill better wells, but we can drill them faster, which saves us money. Now we're getting into the world of, hey, I need to better monitor how this well is being drilled in real time. And it's important when you think about the world of unconventionals, because when you're drilling in a shale formation, it's important to stay in that target zone. You want to stay in that target zone as close to 100% as you can, because if you deviate from that target zone, and those target zones look like waves on the water, they're not perfectly straight like a tiramisu cake or anything like that. So it's important to stay within those target zones, because the more that well is drilled in that target zone, the higher production rate it's going to have in its first 90 days. And certainly as decline hits, it'll still produce better rates of production during the decline phase. And a lot of companies can leverage digital twin for this as well when they do what if analysis. But we're seeing more and more companies work with their service providers to get that data and work hand in hand with them. And certainly deploying machine learning and real-time data will help. Artificial lift is another key area, because companies have to monitor their equipment, and they want to reduce their production decline rates as well. We're seeing more and more companies also leverage new technologies like Huff and Puff, which is also an interesting technology, because with Huff and Puff, companies are injecting methane into existing production wells, and then they cap them. And when they're injecting methane that they've already purchased. So they need to be able to measure how much production or how much methane that they're putting into that well, because when they bring that well back online, that methane is going to come back out. And being able to know how much you put in when you are bringing that well back online helps you determine how much of that methane is coming back out. So that way you're not paying royalties and taxes on the product that you've put in there. Increasing production performance goes hand in hand with that. And we're seeing more and more operators doing a better job of automating their wells. So being able to have policies and procedures in place and leveraging real-time data to have automatic functions like chokeback and gas lift rates and shut-ins is key, especially considering that, if you have to rely on humans, many times there's delays in doing that. And if you have delays, that could actually cause damage to a well. And certainly being able to analyze, benefits of intermittent production is key, because sometimes if you cap a well, you bring up the pressures and then you uncap it and you're getting a higher performance out of it. So there's a lot of science that's going into not only drilling wells these days, but also the production phase. Surveillance is another key area as well. People, when they think of surveillance, they typically think of, well, we've got to have security and so forth. Well, if you've got security crews that go out from site to site, that's a lot of dashboard time, and that certainly can lead to safety issues. But you also could have sites that are a little more remote, and it's harder for security and personnel to get out to. So we're seeing more of a need for being able to leverage real time from a surveillance standpoint. Companies are also looking to avoid illegal tapping. There's a lot of tapping and vandalism that goes out in the field. And of course, leakage and emissions are two other key areas. Something else to think about too from a surveillance standpoint, drones are putting a lot of data into the system, and you want to be able to leverage that data from those drones, not only for the surveillance standpoint, but also for greenhouse gas emissions and purposes. And also from a surveillance standpoint, we're seeing an increase of companies that have gasoline stations, petrol stations, if you will, being able to leverage those cameras that they have at those stations. And a good example is, it's a nice sunny day. A customer drives into the gas pump. They start filling up their car, and then all of a sudden that customer pulls out a cigarette and lights it. Being able to leverage real-time and artificial intelligence, you can take screen captures, video, or still pictures from those cameras, load them to the cloud in real time, do artificial intelligence, machine learning, analyze that there's a threat, and then notify the operator at that gas station to shut down that pump. And that pump gets shut down. You notify that person, walk out, tell them, please put out your cigarette. And then once the security risk is over, that pump gets turned back on. Automated anomaly detection is also another interesting area as well. Being able to automate the process of determining if things are out of bounds. And a lot of companies, they use, humans. I've been talking about that quite a bit today to do a lot of that work. But being able to get away from a manual process with limited visualization and automating those processes will give a higher reliability of inspecting and maintenance. Being able to leverage autonomous vehicles certainly will help from a risk perspective and hazardous conditions. And you think about how you can utilize robots now for tank inspections. Robots can be used for hulls and ship inspections as well. So the trend is, how do we protect our people and our contractors? And we're seeing, more of this as technology continues to evolve. With logistics and asset optimization, it's an overlooked area. People tend to not think about it. They tend to do business the way they always have. They'll stockpile supplies and equipment and so forth. But think about this. You've got an operating platform off of the coast of Nigeria, and you have an expensive pump that goes down. How quickly can you determine where that replacement pump is in the world? How quickly can you determine which technicians are certified to work on that pump? And then how can you determine out of that group of technicians who has their paperwork and immunizations in order to travel to Nigeria? Because downtime is a key driver of loss of productivity and revenue in oil and gas. The other thing too is companies are using trucks and ships and other things in the field for moving their people and also transporting equipment and parts. And if you can optimize your vessels, then you can use fewer vessels out in the ocean. That's going to save money. That's going to help the environment. In the same token, when you've got workers in the field that are driving, and you can give them real-time updates on their routes to save them time and keep them away from traffic jams or accidents, that's another area of improvement. Field worker support is also key. And there's, as I've talked today, there's been some field worker support kind of sprinkled in when I talked about exception-based field management and those field operators having those mobile devices with the applications on them. And you think about now being able to leverage robotic processes to where a field worker can dictate conditions out in the field, and that can be captured and it can be notated in the system, and then video capture as well. When you can, a worker can capture something by video, it can be uploaded, it can be analyzed. Having that digital assistant is an important piece because it helps from an efficiency standpoint, and also it saves a lot of time. And you can leverage technical and engineering vocabularies as part of that because every job is different. And the other thing to think about as well is we're also seeing more examples of workers in the field wearing sensors to monitor their health and well-being. So there's a lot of areas where we can support our workers, keep them safe. This is a client of ours that they have leveraged data analytics for a long, long time. And when we had the previous downturn in 2016, their data and analytics program really added value to their company because they were so much further ahead of a lot of their competitors because they were doing a good job of analyzing their data to drill better wells and operate more efficiently, but they were doing it in the traditional way, bringing in that batch data, and it took days to get into the data warehouses, and it took time for their analysts to make those recommendations. But as part of that, they ended up drilling better wells. They ended up operating more efficiently and lowering their cost per barrel. They don't hedge any of their forward production, and so when it comes to their production, they're always trying to lower their cost of production, so that way they can be fully exposed to rising oil prices. Another benefit that this client received from partnering with Confluent is they had an issue with their data warehouse, and the business unit that we support was able to go back into Confluent and replay all that data out of Confluent and rebuild their section of the data warehouse in 90 minutes. And this company has done such a great job with their analytics program that they are having financials in today's environment similar to the financials that they had in 2014. And in 2014, they produced more product at higher prices than they do today. Now, the edge is an interesting area, and everyone talks about the edge. You know, there are 4 primary reasons why computing at the edge is needed: privacy, bandwidth, latency, and reliability. An edge solution achieves privacy by avoiding the need to send all the raw data to be stored and processed on cloud servers. Bandwidth and the associated costs are reduced as all raw data is not sent to the cloud. There is no issue of latency when computing occurs at the edge, and it doesn't rely on a cloud connection. Finally, reliability is improved because it's possible to operate even when the cloud connection is interrupted. And we had an interesting observation by one of our clients. So one of our clients is leveraging Confluent at the edge running on HiveCell. They had a truck pull up and it blocked the satellite dish. The truck stayed there for 6 days. When the truck moved, that satellite dish reconnected, and all the data that Confluent had been gathering and processing was uploaded to the cloud. So by being able to leverage Confluent at the edge, we bring stream processing to the field. This client is focused on leveraging Confluent to get them to the point where they can literally have the autonomous drilling rig. You know, the oil and gas industry, when you think about it, it generates a massive amount of data. And with the proliferation of sensors, the data is only going to increase. So the challenge is, how can companies extract actionable business insights from the data so that way they can enable their operations to run more efficiently. When you leverage artificial intelligence with edge computing and IoT applications to transform that data, you can deliver real-time operational intelligence directly to the people and places where it's needed. So the integration of different discrete data sources across your sensors, your devices, or your systems, it requires the data to be analyzed, filtered, contextualized into digital models or profiles of the equipment or processes that are relevant to those operations. So these digital models, they'll continually learn, and then they'll predict the operational impact, such as mobile or fixed equipment health issues, pipeline vandalism, leaking gas, environmental implications, and dynamic truck schedules that will impact loading at terminals to optimize them. So when you think about it, edge computing in combination with IoT applications will enable operations to run more smooth and more efficiently in a predictive rather than a reactive manner. So without Confluent, this is what companies typically have to deal with. They deal with an environment that has been built over time with multiple points of integration and multiple challenges of integrating all those sources. And companies just can't take a clean sheet of paper and erase their architectures. So with Confluent, we literally become that universal event pipeline with all those different data stores and logs, your field data, all those different types of things. We can consume that data and we can serve that data up for your real-time analytics, your real-time field data, vendor, customer 360, machine learning models, real-time data transformations. I mentioned earlier that, our clients take a look at, companies that started off at the cloud, and they appreciate what they've been able to accomplish, but they really do like to focus on peer companies of theirs that do have those monolithic traditional architectures with a lot of point-to-points. And look to those companies as examples of how they can leverage Confluent to modernize their environments and enable the event-driven architecture. So Confluent, just a bit of information on us. We're about 1,300 employees. We're about 7 years old. The founders of Confluent are the creators of Apache Kafka technology. The three of them were together at LinkedIn, and LinkedIn was having all kinds of integration challenges. They did not see anything that they could go out and purchase to fix those challenges. So the three of them sat down and started writing in Scala what would become Kafka. And over time, they refined it at LinkedIn, and it became the central nervous system for them. They then took Kafka and they donated it to the Apache Foundation, and they made it open source. And they saw the adoption being driven rapidly by many organizations, but they also saw that there were some challenges. And those challenges were that, typically open source software is not an enterprise style of application. So they left LinkedIn, who was our very first investor, to start Confluent. And what we've done is we've taken the open source Apache Kafka, which to this day we still write over 80% of at Confluent, and added additional features and functionality to it to make it truly a enterprise class event streaming application that is a hybrid application, meaning that it can be run in a data center or on one of the cloud providers, fully self-managed by our clients, or our clients can run or subscribe to our fully managed cloud solution, where Confluent does all the heavy lifting of the technology and our customers focus on the data. Being a hybrid style of approach is key to our customers in oil and gas, because so many of them still have a tremendous amount of data on-prem, and they need to be able to integrate that on-prem data from on-prem to the cloud, to the various cloud providers and back. And also, you think about what we can do from the edge perspective. So we can offer our clients a full edge to data center or edge to cloud solution to enable them to run their businesses in real time in an event-based perspective, if you will. We are currently the fastest growing company in either Sequoia or Benchmark's portfolio. And we're very, very proud of the value that we bring our clients across all industries. We are a recipient of JP Morgan's Innovation Award, CIO Innovation Award. And this comes from the fact that we've partnered with them and not just been someone who provided software or service, but work with them on their use cases, understood their business, and brought real value to them. And here's some customer quotes that I'll let you read. And another page. So we partner with our clients. We know that there is a journey that they go on. We want to be with them every step of that way. We want to be a valuable partner that helps them leverage Confluent to be truly their central nervous system. This is my contact information. And with that, I think we will go to Q&A.
Just as a reminder, you can ask your questions using the Q&A button at the bottom of your screen.
All right, so I see a question about which sector do we find the need for most help, upstream, downstream, or midstream? I would say it's fairly equal. When you think about the world of upstream, you see challenges obviously from a standpoint of drilling better wells and producing better production volumes and lowering the costs. But you also see challenges from a downstream perspective, because downstream operators, they have to do a good job of managing their operations. They've got all kinds of different equipment in those refineries. So many refineries were built before the digital age, and as refineries undergo maintenance, more and more aspects of those refineries are becoming digitized. Those refineries also have SCADA systems, just like Upstream does. Those SCADA systems produce a lot of data, but the challenges are being able to compile that data from the various systems in real time and be able to monitor the operations in real time, being able to take data from historians and so forth. There's a lot of data that's produced, but being able to leverage that data for actionable intelligence is key. And in the upstream side, like we've talked about quite a bit today, they've got SCADA data coming in and from various sources and systems, and they've got to be able to utilize that data in order to know that not only are they drilling better wells, but their operations are safe. In the midstream space, you've got all the different pipelines, and certainly you've got pipelines that span long distances, and you've got stations along the way for all those pipelines that ensure that you've got the product moving, and product will be impacted by temperatures. You've got to be able to monitor that. You need to be able to monitor pressure. You need to also think about this as well from a midstream perspective. A lot of companies are now flying drones over pipelines. They're looking for foliage. They're looking for threats. They're looking for things that can impact pipeline integrity. So I would say it's all the above when you think about the oil and gas industry. Traditionally, the oil and gas industry, when times were good and oil was well over $100 a barrel, there wasn't nearly as much emphasis placed on, taking the data that's produced and squeezing every bit of value out of it. Now, in this lower for longer environment where companies are trying to get as efficient as possible, they're looking for the most insight they can out of their data. So we have a question saying, how long does it take to set up the logic and get data from source systems, et cetera?
So I can answer that. I was typing in an answer for a follow-up question, but the short answer is that data that's made available to Confluent is consumable by applications in real time. So no matter what the data, if it's program information, if it's actual data, if it's actual flat files, as soon as that data is given to Confluent, then any application can read it immediately. The way that we achieve real time in that sense and such, rapid speeds is that we take advantage of the memory of the operating system. So most requests and such, most data exchanges are actually happening in memory in Confluent. So there's a follow-up question, which is essentially, okay, I understand, real time, but how long does it typically take to set up the logic, get data from source systems, et cetera? So that's actually a great question. So Confluent is agnostic when it comes to what type of data makes it into Confluent. So like I mentioned, if you look at, let's say, industrial IoT and OT protocols, that's typically technology that is not usually real time and is not usually networked. So you can use technologies. There's a bunch of technologies you can use to get access to that data, or you can do things like export that data, to flat files and such. So Signet is one common technology, for example, that a lot of industrial IoT data is, presented from. So that being said, any data that reaches us, whether it's real time or not, whether or not it's a cloud native technology, or whether it's a friendly protocol like MQTT, can be consumed in real time. So for popular sources and sinks of data, Confluent provides something called connectors. So instead of having to create an application that captures data and places it into Confluent, A connector is a pre-built piece of software that instead of you compiling code to talk to a system, you actually just configure a connector and say, here is my, let's say, MySQL database, or here is my Teradata data warehouse, or here is my instance of Snowflake, and here's my credentials. Take, take all of the data or take a subset of the data and place it into, Snowflake. So when it comes to how long does it typically take to set, such an environment up, once again, if you have cloud native technologies and, kind of popular cloud enabled technologies, things like MongoDB and Elastic and such, you can be up and running in less than a day. Now, if you have extremely important information that resides in a custom place, or if there's very complicated business rules to get access to that data, maybe you have to do some integration in SAP or consume from an alternate method from the mainframe, it will depend on how much coding you have to do to get to that technology. Once again, whether or not there's a pre-built connector, and of course, your expertise. So, it's really pretty simple to start moving data through Confluent. Now, once you have this data, and obviously you want to do things like create insights from that data. So the other critical innovation from Confluent is the ability to create stream processing applications in real time. So when you have data moving through the system, we have a technology called KSQLDB where you use a SQL-like syntax to create stream processing applications. So what I mean by that is, select star from the sources of data, which we call topics, select star from topics where, compressor information is not nominal, and then create a new stream of data that shows, possible, compressor issues, possible pipeline issues, possible, fraud or theft. And then any application that wants to can consume that curated data in real time. So this stream processing application that you create is looking at data and it's actually creating a new stream of data in real time. So if you create an application, you're not looking backward in time. Any new events get created and placed on a new stream of data. So, once again, if you're simply moving data and you have relatively simple data sources, it's quite easy to get up and running in less than a day. What we find with our customers is, the more difficult it is to get data, or if you have many, many, many sources of data and many consumers of that data, then you want to spend more time architecting what the system looks like and who should have access. If you have one team that is essentially maintaining it, placing the data, and consuming the data, that's not very difficult. When you start offering organization-wide services or global services, then you want to care about what teams have access to which resources. So then you start considering, HR should have read-only access to this data. Everyone that's an operator should be able to read and write the data. Anyone that is a data scientist should be able to read the data, but not directly from the system. Maybe they want to read it, from Azure Data Lake or, Snowflake or something like a Teradata data warehouse. So, it's a it's a great question, Troy. There's unfortunately a lot of answers depending on what you're doing. For simple monitoring or real-time data movement, our customers are up and running very, very rapidly. Obviously, it takes more time if you have, more difficult protocols and technologies, or if you're doing like an entire enterprise-wide service.
Now, I'll add to that. Dave, you talked about stream processing, and stream processing, I highlighted it earlier as we were talking at the edge. And one of the benefits there is when you take a look at cloud platforms and the cost that people have with cloud platforms, it's based upon how much they're storing on those cloud platforms and how much compute they're doing. And by leveraging Confluent for stream processing, especially at the edge, it reduces the amount of data that you're sending to the cloud. So that saves our customers a lot of money. And also helps them with connectivity challenges that they may have in the field. So stream processing is certainly a fantastic benefit of partnering with Confluent. And the other thing too, from a partner perspective, I mentioned about running Confluent on HiveCell, and HiveCell is a OEM relationship we have with the HiveCell team. And that is a service to our clients with HiveCell hosting Confluent on all those HiveCells. And we also partner up with companies like Verizon, who provides that backbone from the field and that connectivity. So we try to give our clients a end-to-end solution, and we feel like we can certainly help them save money by being able to leverage our technology to save them money on their cloud costs, but also all those benefits from those use cases. And there are more use cases, certainly. From a time perspective, I didn't want to drone on for about an hour and a half on all the various use cases. But when you think about all the different things that are considered events in oil and gas, Confluent can be leveraged for all of those. And as I highlighted earlier, so many companies are focused on keeping their production flat. They're not going to go deep into debt to produce at all costs. It's a different world of discipline that we're in now. And so if companies are not going to produce as much product as they used to, and oil prices are kind of like they were previously, how are they going to increase their profitability? Well, they've got to leverage technology. They've got to do a better job of running their businesses in real time, running their businesses on an event-based architecture, if you will. And we feel like we're very well suited to help our clients and enable them to be profitable in a challenging environment. You take a look at the world of oilfield services. Those companies are tasked with supporting their customers. That industry has gotten very, very lean through what we experienced in 2020. Those companies don't want to be in the business of writing and supporting software. They want to be focused on supporting their clients and making their clients successful and keeping their clients happy. Because when oil's $80 or $90, it's still a very competitive industry in the world of oilfield services. Now you get down to $50 and $60, it's even more competitive. And so we feel like by partnering with these companies and them offloading their data needs to Confluent, they can then focus on those applications that directly support their clients, keep their clients happy, while also increasing their customer base. So our goal is to not only help producers in oil and gas produce more product at a lower cost and operate safely, we want to help those on the downstream side take that raw product and turn that into finished products in a very efficient way, in a very, very safe way. And then we certainly want to be able to help that midstream side space where product is being transported, and then do a good job of supporting those service providers. We're also seeing more clients wanting to do a better job of sharing data. And that data could be shared with the different services they subscribe to get that data. And it's certainly shared with the service providers that do work with them. And more of these organizations don't want to do batch. They don't want to do ETL. They don't want to do things that are time consuming and expensive. They want to be able to leverage Confluent and leverage the speed and the accuracy that we offer and the scalability. Plus, data can be transformed in motion with Confluent. So we've got clients that credit us for helping them save money on hardware, software, service provider, and people costs. And that's really becoming the theme in the environment that we're operating in now.
Great, thank you so much. It looks like that is all the questions that we have right now. So thank you, John and Dave, and thank you everybody for joining today's webinar. If you do have additional questions, please reach out. We will also be providing their contact information in the follow-up email. As a reminder, you can now register for our 6th annual Machine Learning and Oil and Gas Conference that we have coming up in April. For a list of all of our events, you can visit energyconferencenetwork.com. Also, be on the lookout for more information about Confluent's next webinar taking place next month. Thank you and have a great day.